right, so this one is about a party. People are arriving and people are leaving. They do this all the time on the AP exam. I cannot think of a test in recent memory, and I mean like going back decades, where they do not give you a rate in, rate out problem. Like it will be on there. They give you a rate of something going in and something going out. So this one's about a party. So the rate of people arriving is the A of t function, and then leaving is L of t. That's just 5. That's constant. So the rate at which people are leaving is 5 people per hour. And again, it's something per something else because it is a rate. These are both rate functions. So rate in, rate out. Okay. So letter A, at what time is the party the most crowded? Again, you want to think maximum, which means critical point. And how many people are there? All right, so critical point means derivative equals 0. These already are derivatives because they are rates. Comparing that to one that we just did, you're like, well, hey, Ms. Cole, in the M&M problem, the E of t, that already was a rate, and we still did a derivative of that E prime. That one was worded strangely. It was being devoured the most quickly. It was like a rate of change. This is just we want the most people, the most people. So if you do a derivative of people, you get people per hour, and that's what these already are. So these already are the derivatives. So we're going to do rate in minus rate out and set it equal to 0. Again, critical points are derivative equals 0. So this is 40e to the negative t minus 5 equals 0. Again, it's rate in minus rate out equals 0. So we will add over the 5. And here's where I'm going to need to pick up a calculator for this. All right, so we're going to go into y equals, clear all that out. And we're going to put the 40e to the negative t into y1. Again, I'm going to type x instead of t, so 40e to the negative x. And then 5 goes into y2. And we're going to hit graph and look at where they intersect. And I'm going to hit zoom 6 just to start it out with standard. If you aren't given a window, zoom 6 is a good idea. You can always adjust it from there. But this looks good. We can see what we need. All right, so what I want is this intersection. So we want to know where these are equal. So we're going to go to calculate. It's second choice. And I'm going to choose number 5 for intersect. And it's going to ask me 3 questions. It's going to do first curve, second curve, guess. Basically, you can just hit enter for all of those. First curve, enter, second curve, enter. You can't mess that up because there's only 2 graphs on there. For guess, if you want to, you can move the cursor close to the intersection. In this case, it doesn't really matter because there's only 1. If there was more than 1, it would kind of matter, but here there's only 1. And then hit enter, and it will tell you your answers. So again, we talked about this last time. How many decimal points do we need, guys? Where they will actually not give you credit. Like you need 3. If you forget on the AP exam, write them all. You can do more than 3, but you need at least 3. Okay, so this is time 2.079, and time was hours for this party. So around 2 hours, 2.079 to be specific, is when the party is the most crowded. That's when it's the most hopping. That's when everybody's there, is about 2 hours in. Now there's a follow-up question. How many people are there? So that means we need to accumulate people. That's going to be an integral. We need to accumulate people from 0, which would be the beginning of the party, until this time. So what I'm going to do is store this value. I'm going to store that as A. I'll show you how to do that in just a second. We want to integrate or accumulate people from 0 until this time. I'm going to copy paste it. And then it would be rate in minus rate out. So 40e to the negative t minus 5 dt. Or again, you can write a of t minus L of t. I know I said you can do that because it's faster. These equations were really short in this case, so I just kind of wrote them like that. All right, so the way you can store this as A is quit out of here, just leave, go to the home screen. If you hit X, enter, the glare is really bad there. Hit X, enter, it will bring it back. And then you can store it as A. So store alpha A, enter. So hit X, enter, that will bring it back. Store alpha A, enter. And then I'm going to type this integral. So math 9, 0 to A. And I'm sorry, I know I'm typing this stuff kind of fast. I want to make sure that I finish everything. You can always watch the video again or come see me during office hours and I can go through button by button what to press here. But you guys are going to have to be able to do this to get through the AP exam. Like you are going to have to get through the button pushing. It's part of what they're testing you on. Right, and so we get 24. Now you could round to the nearest whole person and say 25 people, but I always think it's funnier to just do the decimal. So around 25 people at the party. That's a lot of people at a party. Well, I guess it depends on how big the venue is. If that's like people at your house, that's kind of a lot of people to have over. I don't know what kind of party it is. All right, letter B. Set up the integral equation that would give the time x at which everyone is gone. The loss of his leg and 3 front teeth. Yeah, I know. That's why I always think it's funny to do the decimal because it's like, oh, he was halfway out the door, you know. So this is like the M&M problem where the bowl was empty. We want to integrate from 0 to whenever. I don't know what that time is. Rate in minus rate out. And we want it to equal 0. It's where everyone has left. You don't have to go home, but you cannot stay here, kind of thing. Everyone to be gone. And then C, what is the net rate at which people are arriving at time 4 hours? Now, these equations are rates. So you don't have to do a derivative. You don't have to do an integral. All you have to do is plug in 4. So it would be 40 e to the negative 4th. I'm just going to plug 4 in for t, and then minus 5. So this is the rate at which people are arriving at time 4. And then the rate at which they were leaving was constant 5. So let's type that in. Let me clear all this out. 40 e to the negative 4th minus 5. And so we get negative 4.267. And hey guys, I'm going to throw this question at you. What are the units for that? Remember that it is a rate, so there should be a per in there. What are the units for this answer? Good, nice job guys. People per hour. And the fact that it's negative, what does that mean? Since we got a negative rate of people per hour, what does that mean going on for the party? People are leaving. Good, they're leaving, but they're leaving what? Because people are still arriving. Oh no, I wasn't correcting your grammar. I don't care about that. Good, there, perfect, nice job, Anna. That's exactly what faster. People are leaving faster than they are arriving. So you get a negative net rate. So people are still arriving and people are still leaving, but if they're leaving more quickly, then you get a negative rate. Nice, good job. All right. And then last one, I love this problem. This one's about a gopher and a monkey. Math word problems are always so silly, right? A gopher is 10 feet below the surface of the ground. That is his initial condition. He's underground because he's a gopher, all right? He's burrowed down into his den, 10 feet below the surface of the ground, right below a tree at time 0 seconds when our story begins. A monkey is 10 feet above the surface of the ground. He's in a tree, in that tree that's right there. So his initial condition's positive 10, again, at time 0 seconds. They start moving towards each other for 5 seconds. That's gonna come up again later, so hold on to that. They start moving towards each other for 5 seconds. The speeds at which they're moving are given by, all right, and then this is the this is the gopher, and this is the monkey. Those are their rates in feet per second, okay? Find where the two animals are at time 3. So find their positions, all right? So let's do the gopher first. The gopher starts at negative 10. He is 10 feet below ground, all right? He moves upwards, so plus, like he's moving towards the monkey. He's trying to burrow out of the ground. Plus, and then we want to accumulate how far he's gone. So that's going to be an integral from when to when. What are going to be our boundaries on that? Good, nice job, perfect. 0 to 3, and then that's the gopher equation. All right, let me type this in for us. It is -10 plus math 9, 0 to 3, and then I'm going to put the gopher equation in there. And I'm going to type x, even though it's t, just because that's more convenient. So it's -10 plus math 9, gopher equation dx. And there's where the gopher is, -5.250. And in this case, you do need to put the 0 because it's not over. There's still more decibels. What was this, feet? So the gopher is still underground. He's not quite as underground as he was, but he's still underground. All right, and then for the monkey starts at +10. He is moving downwards. He's moving down towards the ground. So we're going to subtract off his accumulation. Again, 0 to 3, and this time it is the monkey equation. So he starts at +10. He's moving downwards. So I'm subtracting off his accumulated motion from 0 to 3. All right, so this is going to be 10 minus math 9, 0 to 3, and I'm going to type in the monkey equation. Someone asked, how does this come out to be a value when there's variables in the equation? It's because of the boundaries. What your calculator is doing is an antiderivative and then upper boundary minus lower boundary. So when you plug in those numbers, you get a numeric result. Now, that's a good question, because I get people that will try to type in like numbers instead of variables here, and that's not going to work. Also, here, let me hit enter, and then I'll show you another no-no that I see all the time. All right, so the monkey is at 6.7 feet. I get this all the time. People will go to y equals, clear these out, and try to type in like an integral there. Don't do that. You can't do that. That's not a thing, okay? Don't go to y equals and try to type in an integral. You can do integrals on the home screen. That's it. Letter B. When, so it should be a time, when are the two animals traveling at the same rate for the first time? All right, so we're going to set these rates equal to each other. And you could just write g of t equals m of t. I wrote out the whole thing so you can see what I'm about ready to put in the calculator. So when are they traveling at the same rate? We're setting the rates equal for the first time. So that means these are going to intersect a few times. We want the first one, and then how fast are they going? So we're going to go to y equals, and we're going to put the gopher equation into y1 and the monkey equation into y2. Again, I'm sorry, I know I'm typing this fast. I want to finish the problem. Again, you can always go back and watch the video again. Okay. I'm going to hit zoom 6. All right, so there's the gopher equation, and here's the monkey equation. They do intersect twice in there. It's really, really small. I'm going to zoom in on that. All right, so again, there's the gopher equation. Here's the monkey equation. So we want the first intersection. So I'm going to do second trace, choose intersect. And again, it's going to do first curve, second curve, guess. This time the guess does matter because there's two intersections. First curve, enter, second curve, enter. For guess, you just want to move the cursor closer to the first one. And so this is your answer. That's the time. And then the follow-up question was, how fast are they going? It's cool. They give you that too. These are the rate equations. So this is their rate at that time. So this is the time, the x value. And then this is the rate at which they are going. We just need to slap some units on the end of those. All right, so it's at time 0.075 seconds. And they are going 0.815 feet per second. So not very fast. So that's the time, and then at that time, that's the rate that they were both going. And then last one, I got 5 minutes here. I can finish this last one. When are the animals closest to each other? Remember I said this was going to come up again. They move towards each other for 5 seconds. So when are they closest? 5 seconds. Good. They're closest at time 5 seconds. If they move towards each other for 5 seconds, then they're closest to each other at 5 seconds. How close are they? Here's what we're going to do. We're going to repeat exactly what we did in part A, except instead of 3, we want to plug in 5. That's the only difference. So let me show you the fastest way you can do this. I'm going to go back to the home screen. And I'm just going to hit the up arrow until I get this back. This was the gopher. And I'm just going to go back and change the 3 to a 5. And you can just type right over top of it. So I hit the up arrow. I hit enter when I got there. I brought it back. I just changed the 3 to a 5. And so here's where the gopher is. 2.749 feet. So, hey guys, where's the gopher? He's above ground. Not only, this is one heck of a gopher. I love this problem. Not only did he burrow out of the ground, he started climbing up the tree. That's so cool. All right. And Christina, I saw your concern. That's a valid concern. I would say, there are a lot of moving parts to these, but we're going to do a lot of practice. And remember, you can get points for the units, and you want to view each part individually. Just because if you can't get part A doesn't mean you can't get part B and C. So, we're going to do a lot of AP review. So why is the monkey so slow? All right, so for the monkey, I'm going to go back up and get the monkey integral, and I'm just going to change the 3 to a 5. And here's where the monkey is, so 3.5 feet. But that actually isn't the final answer to the whole thing, because the question is, how close are they? So what do I need to do to answer that? Yeah, perfect. Good. I like how someone wrote monkey minus gopher. I love that. All right, so here's what I'm going to do. 3.5, that is just a whole decimal. I'm going to go back up and get this answer and bring it back. So I have that one, and I'm going to subtract 3.5. This is going to come out negative, but I'll just turn it positive. I'm going to absolute value this. All right. So 0.750 feet apart. So they're pretty close. I wonder what's going to happen.